In this video, I get to show you a powerful tool for integration called u-Substitution, which we will use throughout the rest of this AP Calculus course. The thing is, at this stage in the game, we only have a couple of ways to integrate. We have the power rule of integration, a couple of trig rules, and that's about it. This problem right here doesn't fit any of the rules that we know. However, we can use u-Substitution to rewrite this in a simpler way that will fit one of our rules, and then we can find the indefinite integral. Here is the key to the whole shebang. You know how y prime can be written as dy dx, right? Well, this is u-Substitution. So here's where the letter u comes into play. Instead of y prime, I'm going to write u prime. So it makes sense that u prime will equal du dx. And a long time ago, we learned that when we have something equal to a fraction, we are allowed to swap the value with the denominator. So if we swap the dx with the u prime, we're going to end up with this. Dx is equal to du over u prime. Soak this in, people. This is the key to everything. In fact, if you're going to memorize one thing for today, this is it. Dx can be replaced with du over u prime. So where does this u come in? Well, this is going to work similarly to the way we did the chain rule when we were doing derivatives. When you have something inside of something, like a function inside of a function, you're going to imagine replacing that with the letter u. So in this case, I'm seeing that we have 3 minus 4x squared. That would be a good possibility to replace with the letter u. So off to the side, let's write this. Let's let u equal 3 minus 4x squared. Now, the next step is crucial. We also need u prime, which you see right here. So we take the derivative of this. The 3 goes away. 2 times negative 4 is negative 8. We reduce the power by 1, so we get negative 8x. For u-Substitution to work, it's important that we have some things that will cancel out. So notice that we have this u prime, and it is showing up elsewhere in the problem. Always look out for that. When you're trying to do u-Substitution, the derivative of the thing inside should appear somewhere else in the function in order for this to work. So now we're going to use this feature right here. Let's go ahead and do the substitution. So we have the cube root of 3 minus 4x squared. We just decided that 3 minus 4x squared will now be called u. So this becomes the cube root of u. Now, for now, we still have this negative 8x sitting here. But what about the dx? We want to replace this with du somehow. And here's where this box comes in. Dx can be rewritten as du over u prime. So I'm going to replace dx with du over u prime. Well, u prime is negative 8x. So I'm going to put negative 8x. Now, notice that we have negative 8x in the denominator, and we have negative 8x right here. So these are going to cancel each other out. So that leaves us with the integral of the cube root of u du. This simplified version fits one of the rules that we have. We can use the power rule. In fact, let's go ahead and rewrite this. Instead of the cube root of u, let's write u to the 1/3 power. So by the power rule of integration, we can increase this by 1. So I'm adding 3/3. So this is going to become u to the 4/3 power. And then we divide by the new exponent, which becomes the reciprocal 3/4 in the front, and then plus c. But in the end, we need to get the x's back in here by substituting the value of u. u is 3 minus 4x squared. So let's now put that back in. So this will now become 3/4, and then we have u to the 4/3 power, but u was 3 minus 4x squared. And that's it. That's how you use u-Substitution to find the antiderivative. Because this is an introductory video, I'm going to be showing every single step. But in the next video, I will start showing you how to skip some steps that will allow this process to go a little bit faster and more smoothly. Before we do problem number 12, remember dx can be rewritten as du over u prime. Just go ahead and memorize that. So for u-Substitution, you should be looking for a function inside of a function. What do you think? You see the 5x squared plus 4 inside of the cubic function. So that would be a good guess for u. Sometimes it won't always be this obvious, and there's a little bit of trial and error, but this seems pretty clear that our u should be 5x squared plus 4. Now, what about u prime? We always get u, and then we immediately do u prime. 2 times 5 is 10, so that'll be 10x, and that's our u prime. Time to do the substitution. So the x is still sitting there. Hopefully that will cancel out in a minute. The stuff inside here is u. So we have u to the 3rd power. We don't want dx, we want du. So we will write du over u prime. So here it comes. Du over u prime is 10x. Now, what will cancel out? So you see we have the x here in the denominator, and that will cancel out that x. Be careful, we still have the 10 here in the denominator. So this will come to the front as 1 over 10 because it is in the denominator. So on my next step, I'm going to write 1/10 in the front, and the x is gone, so I have u to the 3rd power du. This we can easily integrate. So let's increase that power by 1. So we have u to the 4th power, and then we divide by the new power, so that would be 1/4. Let's bring down the 1/10 right now, so I have my 1/10 sitting there. This is multiplying, and plus c. So it is time to bring the x's back. So I think I will just come over here like this. Well, 1/10 times 1/4 is obviously 1 over 40. So now we have u to the 4th power. So I'm going to leave a little space. So I've got u to the 4th power plus c. But u is 5x squared plus 4. So I've got 5x squared plus 4. Yes, kids, it's just that easy. We're done. Hey guys, have you memorized this yet? Do I need to still keep writing this down? dx equals du over u prime. Please memorize this immediately. Now, what do you think our u should be? What do you see inside of something? Well, I see x to the third power plus 2. Probably that's going to be the u. So u equals x to the third power plus 2. Now let's find u prime. U prime is equal to 3x squared. See the x squared? See how there's x squared elsewhere in the problem? That's how you know this is working well so far. Let's go ahead and do the substitution now. So we have the integral. This x squared is still there, but we have the square root of u. And in fact, because I know where this is headed, instead of putting the square root of u, I'm going to put u to the 1/2 power right now. Instead of dx, we will put du over u prime. So here it comes, du over, well, u prime is 3x squared. 3x squared. So the x squared is in the denominator, and it will cancel out the x squared that's in the front. So that's gone, forget about it. We still have this 3 in the denominator. I'm going to put it out front as a 1/3. So I have 1/3 u to the 1/2 power du. This is a nice, simple problem. So let's do the power rule. Adding 1, so I'm adding 2 over 2, so that will be u to the 3/2 power. And then I divide by 3/2, so it ends up as the reciprocal 2/3. Don't forget about the 1/3 that is in the front and the constant of integration. Now let's put those x's back in. Well, 1/3 times 2/3 is going to be 2/9. So I have 2/9 u to the 3/2 power. So this is u to the 3/2 power plus c. But u is x cubed plus 2. So we go x cubed plus 2. Brilliant. Absolutely brilliant. Number 20. Where's the u? Do you see it? Probably 4x to the third power minus 9 sitting here inside of the cube. So let's let u equal 4x to the third power minus 9. And then let's immediately write u prime. 3 times 4 is 12x squared. And that's gone. Let's do the substitution. For now, we still have 6x squared sitting there in the top. But in the denominator, we now have u cubed. Instead of dx, we will write du over u prime. So here comes du over u prime, which is 12x squared. 12x squared. What cancels? Luckily, this x squared cancels out with this x squared. We still have 6 over 12, which is 1/2, which we will put out in the front. So we have 1/2 times the integral of, and this would be 1 over u to the third power. But to get ready for the power rule, let's go ahead and write this as u to the -3 power. Power rule time. Add 1 to this exponent, so that will be u to the -2 power. And then divide by that power, so this will be -1/2 in the front. Let's bring down the 1/2 that we already have and multiply and put the constant of integration. But we need x's back in here. So let's get this 4x to the third power minus 9 back in. Well, multiplying the constants, we have negative 1/4. And then we have u to the negative 2 power plus c. But u is 4x to the third power minus 9. So we could leave the answer like this. But it would also be cool if we dropped this down to the denominator. So if this were a multiple choice question, you might also see the answer written this way. All right, which part do you think is the u in this problem? Actually, hold on a minute. I think I will not use u-substitution for this problem. Let's see if we can solve this one without u-substitution. So we could square the 3 and the x. So this will become the integral of x squared plus 1 over 9 x squared dx. Sometimes once you've learned u-substitution, you start to want to use substitution for everything. But that's not always the best tool. Sometimes the old methods are best. So we can take the integral of each of these separately. Let me rewrite one more step first. So x squared is good the way it is. I think I will rewrite this as 1/9 times x to the negative 2 power. So we can integrate each of these just using the power rule. So for the first term, increasing this power by 1, we have x to the third power, and then we divide by the new power, so that is a 1/3 in the front. I'm going to just bring down the 1/9 for now. Increasing this power by 1 gives us x to the negative 1 power. Dividing by that negative 1 is just going to change this positive 1/9 into a negative 1/9. And then the constant of integration. So that's actually much easier than doing any kind of u-substitution. Number 28 says solve the differential equation. This is a differential equation because it has a derivative in it. Solving the differential equation just means undoing this derivative and getting y by itself. We can accomplish that by taking the integral of both sides of the equation. The integral of the left side will simply be y. And then on the right side, we have the integral of 10x squared over the square root of 1 plus x to the third power. This is looking like u-substitution. You see that we have a function inside of the radical. So probably that will be our u. So let's let u equal 1 plus x to the third power. And then what about u prime? So putting the 3 in the front, we will have 3x squared. Let's go ahead and make that substitution. So we have y equals the integral of, for now we still have this 10x squared, but in the denominator we have the square root of u. Instead of dx, we will write du divided by u prime, which is 3x squared. What cancels out? Luckily, this x squared cancels out with this x squared. We still have these constants sitting around. We have the 10 and the 3. So this is going to make a fraction out in the front of 10 over 3. That's going to leave 1 over the square root of u. But because of the power rule, it will be better to rewrite this. The square root of u is u to the 1/2 power. So 1 over the square root of u is the same thing as u to the negative 1/2 power. So now we can go ahead and integrate this. So adding 1 to this exponent is going to give us u to the positive 1/2 power. And then we divide by that new power. Dividing by 1/2 is the same as multiplying by 2. And then don't forget we have this 10 over 3 out here in the front. And we need the constant of integration. But now we need to get the x values back in here. So let's write y equals 10 over 3 times 2 over 1 is 20 over 3. And then we have u to the 1/2 power. Let's go ahead and put square root back into this. So u to the 1/2 power is the square root of u plus c. So remember, u was 1 plus x to the 3rd power. And that is it. Let's box it up. Looks like we got a trig function, y'all. Let's review the rules off to the side. So remember that the derivative of tangent is secant squared. For that reason, the integral of secant squared is tangent. Similarly, the derivative of cotangent is negative cosecant squared. Therefore, the integral of cosecant squared is going to be negative cotangent. So keep this in mind because we have cosecant squared. The integral of cosecant squared will be negative cotangent. But first we need to do our u-substitution. Inside of the function, you see this x over 2. So that will be our u. So u is equal to x over 2. Well, u prime is just going to equal 1/2. Interesting. So let's go ahead and make this substitution. So we have the integral of cosecant squared u. Instead of dx, we have to write du over u prime, which is 1/2. Dividing by 1/2 is the same as multiplying by 2. So really, I can go ahead and put a 2 in the front because of that. As I mentioned in the review, the integral of cosecant squared is negative cotangent. So we have negative cotangent u plus c. Don't forget the 2 in the front, which will now be a negative 2. Time to get the x's involved again. So u is equal to x over 2. So we have negative 2 times the cotangent of x over 2 plus c. And that is the final answer. Last one, let's go straight to our u-substitution. Now, what do you think u should be? What do you see that's inside of a function? Well, I see tangent x is on the inside of this square root. So let's let u equal tangent x and see what happens. Well, immediately we need u prime, and the derivative of tangent is secant squared. This is very promising because we see secant squared elsewhere in the problem. So let's go ahead and do this substitution. So now we have the integral of the square root of u. And in fact, I will go ahead and put u to the 1/2 power. We still have secant squared x, but instead of dx, we will write du over u prime, which is secant squared x. Look what cancels out. We have secant squared x here and in the denominator. So these are now gone. This leaves us with the integral of u to the 1/2 power du. Using the power rule, we will add 1 to this, which will give us u to the 3/2 power. We will divide by the new power, which becomes the reciprocal 2/3, and the constant of integration. Time to get the x's back involved. So we have 2/3 u to the 3/2 power plus c, but u is tangent x. And that's it. That's how you do it.